works through the hormones, and hormones take time to perform action. Nerve signal transmission is very fast, but hormones must be produced or synthesized, then should be released, right? And after the release of the hormone, hormones should go to the target organ and then will work on it, will bind with the receptors and work on the target. So you see that endocrine system produces hormones, hormones are released, then transported by the blood and then go to the target organ, then bind with the receptors of the target organ, then work on them. So each action takes some time. So the endocrine function is much slower than the nervous function. But both are powerful control systems of your body. Now, since the endocrine system works through the hormones, this system consists of the endocrine glands. Those glands are located in different areas or locations in your body. First, we'll see the properties of the endocrine system. Then we'll talk about the important endocrine glands. We'll see their locations and just important functions. Then we'll talk about two very important structures in your brain. One is called the hypothalamus and another is the pituitary gland. These two are very important structures in your brain because pituitary gland is called what? Master gland, right? Master gland. It controls the other endocrine glands of your body, right? That's why it is the master gland. But hypothalamus is the master of the master. That means hypothalamus is the boss of the pituitary gland, sitting above the pituitary gland, and it is controlling the pituitary secretion. So that's why hypothalamus is sitting above the pituitary gland in your brain and always talking to the pituitary gland. So we'll see how these two structures are connected. Then we'll talk about the pituitary hormones. Pituitary gland has two parts, anterior and posterior. Just know that anterior pituitary produces 6 hormones. How many? 6. And posterior pituitary releases 2 hormones. We'll talk about those hormones, 6 and 2. Then we'll see how the endocrine hormone secretion is controlled or regulated. You know, sometimes glands secrete more, right? Hormones, sometimes less. So how that secretion is controlled. Then we'll talk about the other endocrine glands. So first we'll talk about the pituitary, then we'll talk about few other endocrine glands in your body. The properties of endocrine glands or system. In the body, we have both endocrine and exocrine glands. Those are two types of glands. So endocrine glands, if you see an endocrine gland, this is the endocrine gland. Inside the gland you have the cells, and these cells secrete the hormones, and inside the gland you have the blood capillaries. So these are the capillaries inside the gland. And what happens, these cells, endocrine gland cells, secrete the hormone where? in between the cells, in the interstitial space. So this is the interstitial space where the hormone is secreted just outside of the cell, and from there the hormone enters into the blood capillary, that means into the blood, and that blood takes the hormone out from the gland. So blood gets the hormones from the interstitial fluid or space and takes the hormone out from the blood. Make sense? In case of exocrine gland, these are the cells of the gland, and inside the gland you have ducts. Ducts are tubes, tube-like structures. So you have the ducts or tubes, and the hormones are directly secreted into the tubes. So we'll go from the cell to the secreted from the cells to the tubes or ducts, and the ducts take the hormone to the outside and releases the hormone just outside of the gland, because duct ends just outside of the gland. So the hormone is released not into the blood but outside of the gland. Is it clear? Okay. So we can say that endocrine glands are what? Ductless glands. And exocrine glands have ducts. Hormones are secreted in the interstitial fluid and from there goes to the blood. Hormones are secreted directly into the duct. So that is another thing. Here we say into the interstitial fluid, first and then into the blood. Here directly into the duct. Since endocrine hormones are secreted into the entering into the blood takes the hormone out, and you know that blood circulates everywhere in the body, right? Throughout the body. So the action will be localized or generalized. What do you think? Blood is going everywhere, right? So the action is generalized. In this case, you see the hormone is secreted into the duct and just released to the outside of the gland. So this hormone will only work around the gland, not far. So localized action. And since in case of endocrine the hormone enters into the blood, the site of action could be far from the gland. For example, pituitary hormone is released into the blood, right? And can work on the kidney because blood can take it anywhere. So the action is usually far. Action is usually far from the gland. In this case, the action is just outside of the gland. So near the gland. Far from the gland, near the gland. So these are the properties of endocrine system, and these are the properties of exocrine system. If I ask you write the properties of endocrine and exocrine, you will write both, or difference you will put side by side. Important endocrine glands of your body. If you start from the brain and go downwards, inside the brain you have the pituitary and pineal. Those two are important glands in the brain. Both start with P. Pituitary is called the master gland, and you already know that it regulates the secretion of other endocrine glands of your body. That's why it is called the master gland. Another name of pituitary is, anybody? I have mentioned hypophysis. You remember the hypophyseal fossa? Have you heard that? Hypophyseal fossa? Where? Everybody should immediately come. Sphenoid, yes, sphenoid bone, right? Remember the butterfly shaped bone on the body of sphenoid. You have a fossa, hypophyseal fossa for pituitary. So another name of pituitary is hypophysis. And pineal gland, you have already seen, right, when you dissected the sheep brain, and also you have seen in the models. So pineal glands are responsible for a few things. One is circadian rhythm, the sleep awakeness cycle in your body. So day-night cycle or sleep awakeness cycle, that is one. Another is synthesis of melatonin. I mentioned this in my first or second lecture, melatonin. Melatonin is a chemical which is related to your sleep, and also this one stimulates the melanocytes, one type of cells in your skin. Those are called melanocytes. Melanocytes are the cells. They do what? They produce melanin, the pigment, dark pigment that gives the color of the darkness of the skin. So these two are the important functions of the pineal glands. Now if you go down in the front of the lower part of the neck, here, around here, you have the thyroid gland, another important gland. And thyroid gland has two lobes, two lateral lobes. This is one, this is another. These are called the lateral lobes, and these two lateral lobes are connected by a tissue mass structure that is called isthmus. So these are lateral lobes and this is the isthmus. Now thyroid gland is responsible for metabolic activities of your body. Thyroid hormones increase the metabolic activities of your body. Very important. That's why, you know, in hyperthyroidism, have you heard that? Hyperthyroidism, what happens? The metabolism increases in the body, right? Another function is lowering the concentration of calcium in the blood. So that is another function of thyroid gland, thyroid hormones, lowering the blood calcium and metabolic activities of your body. Those two. Now if you see in the back of thyroid lobes, you will see small glands, 4 to 8 in number. The number is not fixed. 4 to 8 small glands are attached in the back of the thyroid lobes, not in the front, in the back, the dorsal surface. Those are called parathyroid glands. And parathyroid glands are very important. Why? Because parathyroid glands increase the calcium concentration in the blood. So opposite, increases the calcium concentration in the blood, parathyroid hormone. So if in your blood the calcium concentration goes down, that is called hypocalcemia. Hypo means less or lower, calcemia, calcemia, hypocalcemia, lowering the calcium concentration. And in that case, the parathyroid glands will release the parathyroid hormone to increase the calcium in the blood. Then if you go down in the upper part of your abdomen here, you have a gland. That gland is called the pancreas. Now pancreas is a mixed type gland. Pancreas is a mixed type gland. Why it is called a mixed gland? Because it has both endocrine and exocrine parts inside it. That's why it is called a mixed. Other glands are purely endocrine. So this one is a mixed type gland, pancreas. Since we are talking about the endocrine system, the endocrine part of pancreas is called pancreatic islets. Pancreatic islets, also called islets of Langerhans, another name. Islets of L-A-N-G-E-R, Langerhans, H-A-N-S, islets of Langerhans. Sorry, okay. Let me write down. Islets of Langerhans, or pancreatic islet in simple way we can say. Now this part, endocrine part of pancreas, releases two hormones, insulin and glucagon. Okay. Insulin lowers the blood sugar, you all know that. That's why diabetic patients take insulin. Insulin lowers blood sugar or glucose, and glucagon does opposite, increases the blood sugar. Okay, so know that glucagon increases the blood sugar, insulin lowers the blood sugar, and by the action of these two, your blood sugar is maintained. You know, always your blood sugar must be maintained or regulated within the range, and by the action of these two. So after you eat, after you have a meal, which one should be released more, glucagon or insulin? Insulin, because your blood sugar tends to go up, right? So more insulin. If you are starving, should your insulin be secreted more? No. You are starving. What do you think? No. Insulin should be released more? No. Glucagon should be released more, right? That will increase the blood sugar. If insulin is secreted more, when you are starving, your blood sugar will go further down and you will have hypoglycemic shock. Person may die, right? In hypoglycemic shock. So these two are important. Now, what's the function? Exocrine part, just know that produces pancreatic juice. Pancreatic juice. And this pancreatic juice is very important because it contains all types of digestive enzymes. Protease, lipase, amylase, to digest protein, to digest fats, to digest carbohydrates. So, very important juice. But different function, not blood sugar. Okay, adrenal glands. Adrenal glands are also called suprarenal glands. Why? Because they are sitting on your kidneys. So this is the kidney, and the adrenal gland sits on the kidney like a cap on the kidney. That's why this is also called what? Suprarenal gland. Supra means above, renal means kidney, above the kidney, the top of the kidneys. So how many adrenal glands you have? 2, because you have 2 kidneys, 2 adrenal glands. Now, adrenal gland is a very important gland, and if you see inside the adrenal gland, you have 2 distinct areas. The outer part is called the cortex, adrenal cortex, and inner part is called the adrenal medulla. And in the adrenal cortex, you have 3 layers. How many? 3 layers. So 1, 2, 3 in the cortex. And these 3 layers produce 3 different types of hormones. 3 layers of the cortex produces 3 different types of hormones. That's why the adrenal cortex is also called like 3 glands in one, because 3 layers work as 3 separate glands, produce 3 different types of hormones. Make sense? So 3 glands in one is the adrenal cortex. We'll see, just know that there are 3 layers in the cortex and they produce 3 different types of hormones. Medulla produces another type of hormones. So that's why as a whole the adrenal gland actually works as a gland that has 4 different glands in it. Adrenal gland, just know the functions, have a number of very important functions. Number 1, metabolism of glucose. So glucose metabolism. Number 2, regulation of minerals. Glucose metabolism, regulation of minerals in your body, like sodium, potassium, magnesium. Those are the minerals. Number 3, strong anti-inflammation. Action, anti-inflammatory action, very strong. Adrenal hormone. Another function, adrenal gland also produces small amount of sex hormones. So production of sex hormones. And the last one I wanted to mention is let's see, glucose metabolism, regulation of minerals, strong anti-inflammation, production of sex hormones, and production of adrenaline. Adrenaline is the chemical, you know, that excites the body. You know, when you get excited, adrenaline secretion occurs. You probably know that. So the production of adrenaline. So these are some important functions of the adrenal glands. Remember those?
The last one is that medulla part?
Medulla part, yeah. Adrenaline, noradrenaline. Another one is called noradrenaline. Same, similar function. So production of adrenaline, and another is called noradrenaline. These are called catecholamines. Catecholamines are the word to indicate adrenaline and noradrenaline. Also, adrenaline has another name called epinephrine, and noradrenaline is called norepinephrine, and together these two are called catecholamines. Gonads. Gonads are testes and ovaries, and gonads produce sex hormones. In case of male, testosterone; in case of female, estrogen, progesterone. Female sex hormones. Okay, here you see the location of those glands. One gland is not listed in this chart, in this slide, that you see here. That's the thymus. Thymus is located here in the upper part of your thorax, below the thyroid gland. And this gland is responsible for immunity, defensive functions of the body, immunity. This gland is interesting. In early stage of life, if you see an infant, the thymus is very big, occupies like whole upper part of the thorax, and gradually it shrinks and becomes like this in adults. Why it is big in early stages of life? Because you know that immunity develops slowly in the body, right? So in early stage the thymus has to work more, but when the immune system is established in your body, the function becomes much less. So thymus gets smaller, but it continues its function. Now, you know that hypothalamus is the boss of the pituitary gland, and it is sitting just above the pituitary gland, and it is controlling the pituitary function. So this is the hypothalamus here, and this is the pituitary gland, and you know that pituitary has two lobes, anterior pituitary in the front and posterior pituitary in the back. This is hypothalamus. Okay, and these are the cells of anterior pituitary. How many hormones are secreted, released? 6. You already know. And from posterior, how many? 2. So these are the cells of posterior pituitary. 2 hormones. Now, the anterior pituitary cells are gland type cells, regular gland type cells. Posterior pituitary cells, these cells are different. These are more neuron type cells. So these are gland like cells, these are neuron type or like cells. That's why the anterior pituitary is called, it has another name, it is called adrenal hypophysis. Hypophysis is pituitary, adrenal means gland like, gland type. Remember A, anterior pituitary, adrenal hypophysis starts with A. That's the anterior pituitary. Posterior pituitary cells are neuron type. That's why this part, posterior pituitary, is also called neurohypophysis because its cells are neuron type cells. So neurohypophysis, adeno means gland, adenohypophysis. Now, interestingly, the hypothalamus controls both anterior and posterior pituitary, but it controls them differently. These are the neurons in the hypothalamus. You know that hypothalamus is in the brain. You must remember that below the thalamus. So these are the neurons in hypothalamus. Okay. And in the hypothalamus, you have the capillaries, blood vessels, and from these capillaries, the blood goes to the anterior pituitary, and this is the blood vessel that takes the blood from the hypothalamus to the anterior pituitary. So what happens is, see here, how the hypothalamus sends signal to the anterior pituitary. It must send signal to anterior pituitary to control the release of hormones from the anterior pituitary. So what happens, these neurons secrete the chemicals into the blood here, and the blood takes the chemicals to the anterior pituitary, and from the blood the chemicals will be secreted here. So these chemicals will regulate the anterior pituitary. So here you see one thing which is important. One capillary, one set of capillary is here in the hypothalamus, another set of capillary is in the anterior pituitary, and these two sets of capillaries are connected by this blood vessel. And in your body, when two sets of capillaries are connected by a blood vessel, that is called portal circulation. So this is a portal circulation in your body. You have only few. So this is called portal system. So hypothalamus sends signal to the anterior pituitary through the blood in the circulates in the portal system. Now, how about posterior pituitary? From these neurons, long axons, not the blood vessels, axons of these neurons go to the posterior pituitary, and the chemical is released from the axon terminal here. So the posterior pituitary receives signal from the axons, and this bundle of axons, you already know, is called a tract. Tract is a bundle of axons or fibers. Make sense? The bundle of axons taking the signal from the hypothalamus to what? To the posterior pituitary. So this tract is called, very simple, hypothalamus hypophyseal tract, because from the hypothalamus to the hypophysis. Hypophyseal tract is the bundle of fibers. And this one is hypothalamo-hypophyseal portal system. Okay. So that's how the hypothalamus sends signal to the pituitary. Six hormones of the anterior pituitary are growth hormone, thyroid stimulating hormone, adrenocorticotropic hormone, follicle stimulating hormone, luteinizing hormone, and prolactin. You have to remember these names, 6. Okay. Growth hormone. This name is very simple, right? Growth hormone helps in what? Growth. You know, we sometimes say that some farms, right? Farms, they use growth hormone to grow the animals. So growth hormone helps in the growth of the body, right? So comes from anterior pituitary and it works in all the tissues of the body, everywhere, but on two structures the action is more. One is the skeletal muscles of your body, another is the bones. So on the bone and the skeletal muscle tissues the action is more. That's why when growth hormone secretion occurs more, the bones grow faster and the muscles get bigger quickly. Now, I told you that growth hormone works on the other tissues too, right? So it works on internal organs too. So it will grow the heart, make the heart bigger, liver or spleen, those organs can get bigger too by the action of growth hormone. And you know that normal amount of growth hormone secretion is required for the normal growth of the body, right? Otherwise body will not grow. So the growth hormone secretion occurs during the growth of the body and helps in the growth of the body. Normal.
How does that work with like acromegaly?
We'll talk about that. Okay?
Okay.
So, make sense? So all of us, we need what? Normal amount of growth hormone secretion during the growth of the body. Now, if the amount of growth hormone secretion is more during the growth of the body, then what will happen? The person's body will grow very big, right? The bones will get very long, the muscles will get bigger, right? So the person will become giant. The body will become very big, large. That is called what? Giantism. Yeah. Giantism or gigantism. Same thing. Giantism or gigantism. If excessive secretion of growth hormone occurs during when? During the growth of the body. Early stage of life, right? When the body grows. You know, at one point the growth is stopped, right? So after the growth is completed, during the growth of your body, your growth hormone secretion was normal, but now your body growth is completed. Now if for any reason your pituitary hormone releases more growth hormone, then what will happen? The bones will not grow in length anymore because the growth has been ceased, right? So bones cannot get longer anymore, but what will happen? Some bones will grow in width, sidewise, thickness, and particularly we see the action in that case is more in the finger bones of the face. So the person's face will get big, the bones will get thick, the mandible grows like forward, and that is called protruded mandible, right? Protruded mandible, pushed forward, and the fingers are very thick. Also, since growth hormone works on soft tissues, the person's tongue gets bigger. So you see the sluggishness of talking. When talks, it gets slow, like kind of sluggish conversation. So that is called acromegaly. So acromegaly occurs due to increased secretion of growth hormone when after the body growth is completed. Make sense? In adulthood. Now, if the growth hormone secretion is less than normal during the growth of the body, the person's body will not grow enough, right? Make sense? So the person will remain short and small, and that is called what? Dwarfism. So normal amount of growth hormone secretion is very important for the normal growth of the body. You know that you have internal organs. If they grow too much or they don't grow enough, both are harmful, both are malfunction. So normal size of heart, liver, kidneys, right? Spleen or liver is important for the normal function. Bigger doesn't mean it's good. So growth hormone also increases the blood sugar. Increases what? Sugar in the blood, and increases the synthesis of protein or production of protein. So those are other two functions, synthesis of protein and increases the blood sugar. Thyroid stimulating hormone. This anterior pituitary hormone goes to the thyroid gland here from the brain, pituitary, it goes to the thyroid gland and stimulates the thyroid gland to produce more thyroid hormone. That's why it is called thyroid stimulating hormone, TSH. Another is adrenocorticotropic hormone. Its name is telling you its function. You remember the adrenal gland sitting on the kidney? It has how many parts? First two, right? Cortex, and outer part is called the cortex, and inner is the medulla. Then if I ask you how many parts in the cortex? 3, right? So now this hormone, anterior pituitary hormone, works on the adrenal cortex, not on the medulla. That's why it is called adrenocorticotropic hormone. Okay, and stimulates the adrenal cortex. Follicle stimulating hormone and luteinizing hormone. These two hormones work on the gonads, testes and ovaries. Okay, and help in the maturation of the sperm and ova, growth and maturation of the sperm and ova. And luteinizing hormone also helps in ovulation, the release of ovum or egg from the ovary. That's the ovulation. So luteinizing hormone specifically works on the ovary to help ovulation, cause ovulation. Then prolactin, another anti-pituitary hormone. This one works on female breast, mammary glands, and this one helps to produce milk, production of milk, prolactin. So these are the anti-pituitary hormones and where they work and what they do. Now posterior pituitary releases two hormones. How many? Two. One is called oxytocin and another is called ADH, antidiuretic hormone. These are two hormones. Oxytocin is important because oxytocin helps in the child birth. Oxytocin causes uterine contraction. Uterine contraction occurs during childbirth, you know that, right? And helps in childbirth. And the uterine contraction is caused by oxytocin, very strong action. Oxytocin also helps in the ejection of milk from female breast. Production is prolactin, but ejection is oxytocin. Two different things, right? So after the production must be ejected out. So when the infant or baby sucks the mother's breast, the brain, pituitary, releases more oxytocin. So that is the stimulation. Okay, goes to the pituitary to release more oxytocin. That ejects the milk. So those are two very important actions of the oxytocin. Now antidiuretic hormone, its name is telling you what it does. Have you heard diuretics? How many of you have heard the word diuretic? One beside, only 3, 4, 5. We often read the word diuretic in articles, newspaper or articles. Diuretics. Diuretics do what? Produce more? Diuretics produce more what? Urine. So antidiuretic will do what? Less urine. Make sense? Opposite. So antidiuretic hormone is the hormone that does what? Produces less urine. Reduces the production of urine. Makes sense, right? Antidiuretic. You know, when blood pressure increases and you cannot control, you go to hospital or urgent care, they will give you the pill that will cause more urine production. Have you seen that? So that is what? That is blocking the antidiuretic hormone, right? So the person will produce more urine. So more urine means body water is getting out, blood volume will go down, right? So blood pressure will go down. So that's why that pill blocks the antidiuretic hormone. So the person will produce more urine. So antidiuretic stop the production of urine or reduces the production of urine. Reduces the volume of urine. And diuretics that we sometimes we say excessive use of diuretics can do what? If you take certain diuretics too much, dehydration will occur, right? Because body will lose water. Coffee is a natural diuretic, right? After you take coffee, the production of urine is more. Yeah, go.
My daughter's school goes
That's
too
fine.
early today.
That's fine.
I'll put it on.
Why?
I missed 2 tests.
You must talk to me immediately.
Yes.
Immediately.
I'll email you
No email, just talk to me. Email will not help.
today.
You have to talk to me face to face, okay?
Okay.
By Monday.
Okay.
Because you have to finish by next week. So if you don't talk with me by next Monday, then we cannot set the time. Make sense?
Yes.
Okay. So, antidiuretic hormone reduces the production of urine. Now you tell me, antidiuretic hormone reduces the production of urine. That means what? It retains the water in the body, keeps the water in the body, right? So blood volume will go up. Make sense? Because water is not leaving the body, the blood volume will go up. So that will increase the blood pressure. So its action is increasing the blood volume, increasing the blood pressure. Is it clear? That is one. Another is antidiuretic hormone. When it was first identified, the scientists, they didn't know that it works on the kidneys to retain the water. What they found first is that this hormone works on the blood vessels of your body and constrict the blood vessels. Vasoconstriction. First, when they identified this hormone, they found the action is on the blood vessels, and this hormone causes the constriction of the blood vessels. And that's why this hormone they named as vasopressin. So later they found this hormone works on the kidneys and retain the water. That's why later it was named as antidiuretic hormone or ADH. Okay. Now, by retaining the water, it increases the blood volume, increases the blood pressure. Make sense? But also, it increases the blood pressure by constriction of the blood vessels. You know, when the blood vessels of your body are constricted, blood pressure goes up. Make sense? So, in both ways, this hormone increases the blood pressure. That's the main action. Okay. So those are two posterior pituitary hormones. Here you see growth hormone I mentioned works on all the tissues, but particularly on the bones and skeletal muscles, synthesis of protein, and elevates blood sugar or glucose. I mentioned already this. Now, you know that a gigantism or giantism person suffers, most of the cases, the person suffers from diabetes mellitus. Almost all cases, the gigantism subject suffers from diabetes. Why? Because this hormone increases the blood sugar, right? So if the person's blood sugar is always high, then what happens? The pancreas always is producing more insulin. Is it clear? So this person's pancreas is always over functioning. Is it clear? Functioning more, producing more, secreting more insulin to reduce the blood sugar, and eventually the pancreatic cells burn out, die due to prolonged hyperfunction, and the person gets diabetes mellitus. Here you see the picture in the bottom right. This is a famous picture. This person, gigantism person in the right, and in the left, that's the normal person. So he was from actually East St. Louis. there is a mural statue over there. This picture is used throughout the world in the textbooks. When I was small, when I studied physiology, I saw this picture. So it's a very famous picture.
So is that East St. Louis in the background there?
Yeah, I guess so. You can tell better. Looks like, yeah. Uh, Gigantism person, actually the lifespan is shorter than normal person because that person suffers from multiple, you know, complexities, diseases. For example, diabetes, the heart function is abnormal because the size of the, organ, internal organ. So a lot of complexities occur in these people. And diabetic causes other complications. The secretion of endocrine hormones is controlled by negative feedback mechanism. Negative feedback. What happens, you know that hypothalamus, you see hypothalamus sends signal to the pituitary, pituitary sends signal to the gland, and gland releases the hormone. So in the blood, the concentration of hormone builds up, increases, builds up. And you know that in the blood, the hormone concentration must be within the range, upper limit. So when the hormone increases in the blood, the concentration increases in the blood. When it reaches to the upper limit, the signal will go to the hypothalamus and pituitary. What kind of signal? Inhibitory signal. Don't send any signal because in the blood already the concentration is high, right? So that's why the broken line, you see, showing the inhibition goes to the hypothalamus, goes to the pituitary, and tell them to stop sending signal to the gland because in the blood the concentration is already high enough. So then the secretion will be stopped, and that's how the regulation of secretion occurs. Negative feedback. And when the concentration will again go down, it will start. Okay. So here one thing you see, diabetes insipidus. There are two types of diabetes. One is mellitus, that is related to insulin and sugar, blood sugar. But diabetes insipidus is due to lack of ADH secretion from posterior pituitary. You already know that ADH does what? Retains the water, right? Reduces the production of urine. So if ADH secretion does not occur, then what will happen? The person will produce plenty of urine, right? And will frequently go to the bathroom, will produce more urine. And that is called diabetes insipidus. It has nothing to do with sugar or insulin. It is related to posterior pituitary and antidiuretic hormone, decreased production of antidiuretic hormone. And usually due to posterior pituitary tumor, when the cells die, this can happen. Okay, so that's all about the pituitary. Now we'll see the thyroid gland. Thyroid gland, I have already mentioned, has how many lobes? Anybody? Already here. Two lateral lobes connected by isthmus. Now, inside the thyroid gland, you have many finger-like structures. So, filled with these finger-like structures, and these are called follicles. So, a lot of follicles inside the lobes. And in the wall of these follicles. These are the cells called the follicular cells. So the wall of the follicles have follicular cells. And in between the follicles, in these spaces, you have another type of cells in between the follicles. These are called parafollicular cells outside of the follicle. Parafollicular cells. So, parafollicular cells are in between the follicles. Another thing, these follicles are filled with proteins. All these follicles are filled with protein, and this protein has a name. It is called thyroglobin. Thyroglobin is the protein inside the follicles. It is a colloid protein. Now you see, if I make a cross section, okay, just cut like this and take a slice, what I'll see the follicles, right? So the follicles are like this. These are the follicles, and in the wall you have the follicular cells. These are the follicular cells, and in between the follicles you have another type of cells. These are called what? Parafollicular cells. So these are the parafollicular cells. Follicular cells produce T3 and T4, those two thyroid hormones, T3 and T4. T3 is called triiodothyronine, and T4 is called tetraiodothyronine or thyroxine. T3, 3 means tri, so triiodothyronine, and T4, tetra means 4, so tetraiodothyronine. It's not here, tetraiodothyronine. Oh yeah, it is there, tetraiodothyronine or thyroxine. If I ask you a simple question, you can answer. Triiodothyronine, T3, right? So how many iodine atoms do you think it has? 3. Make sense? That's why it is called triiodo. In tetraiodo or thyroxine, you have how many? 4 iodine atoms. So in each molecule of T3, you have 3 atoms of iodine. In each molecule of T4, you have 4 atoms of iodine. That's why T3, T4.
Is T3 a precursor to T4? Or?
No, not really. No, they are separate actually. When tyrosine, now let me finish this part. So inside the follicle, you have what? Thyroglobin, right? Protein. So these follicles are filled with protein, thyroglobin. This one. Now, you know that protein is formed by amino acids. You all know that. Amino acids. And one important amino acid in this protein is called tyrosine. Amino acid tyrosine. This is the name of that important amino acid in this protein, and this tyrosine is essential for T3 and T4 production. Why? Because tyrosine, 2 tyrosine atoms bind with iodine. When 2-tyrosine binds with 3 iodine atoms, that molecule is called T3. When 2 tyrosine amino acids bind with 4 iodine atoms, it is called T4. So they are separate, different. The composition is slightly different. Tyrosine binds with iodine. When 2 tyrosine binds with 3 iodine atoms, that is T3, one form of thyroid hormone, and when bind with 4 atoms of iodine, that is another form of thyroid hormone, T4. Now you asked that if they can be interchanged. Before they do that, they must break and release the iodine and tyrosine. Then they can be combined, but it can't be directly convert from one form to another. Make sense? Okay. So that's the T3 and T4. Now, parafollicular cells. These cells, those are located in between, outside of the follicles, but in between the follicles. Those are the cells produce another thyroid hormone called calcitonin. So calcitonin is produced by the parafollicular cells, and T3 and T4 are responsible for metabolic activities, and calcitonin is responsible for calcium regulation. It lowers the blood calcium. So different type of function. T3 and T4 metabolism, and calcitonin lowering the calcium regulation. Now, if someone has lack of iodine, for example, in many developing countries or third world countries, poor countries, the kids, they don't get enough iodine rich food. Okay, so they are not getting enough iodine. Here you can buy the iodinized salt, right? So you can eat. But if your body doesn't get enough iodine, then tyrosine molecules are here in the protein, right? But they won't bind with iodine. Make sense? Because no iodine is in the body. So what will happen? These tyrosines will not be used up. Is it clear? So tyrosine will start to accumulate inside because they are not being used up, not forming T3 or T4. So the amount of protein will increase here, and when the protein amount will increase inside these follicles, what will happen? The follicles will get bigger or smaller? Bigger, larger, right? All follicles will get fat, big, and the whole thyroid gland will get what? Larger, and that can be seen from outside. You can tell this kid got enlarged thyroid gland, right? Because a lot of colloid protein has accumulated inside the follicles, and that is called goiter. Have you heard that? Goiter is the enlargement of the thyroid follicles, right? Thyroid gland, and often seen in poor countries where kids don't get enough, or the countries have lack of iodine in water or in the food. Okay, so that is called goiter. Now if you give iodine rich food to those kids, their goiter will be gone because the protein will be used up, shrinkage of the follicles will occur. The last thing, here you see the upper picture, that boy got goiter. In general, we all know the term hyperthyroidism, hypothyroidism. Have you heard that? Hyperthyroidism means more function of thyroid gland, hypo means less. So hyperthyroidism causes some changes in the body. In hyperthyroidism, the metabolic activities increase. Metabolic activities what? Increase, because we know that thyroid hormones increase the metabolism, right? So if more thyroid hormone is produced in hyperthyroidism, then the metabolism in that person's body will be higher than normal. Make sense? Now you tell me, if your metabolism in your body increases, the heart rate will if the metabolism increases, heart rate will increase. Make sense? It's like when you do exercise, the metabolism increases, right? So heart rate increases. The blood pressure increases, right? How about muscle tone? Increases. How about the body temperature? What do you think? If metabolism increases, the body temperature will go up. So those are tachycardia, or increased heart rate, right? Increased blood pressure, increased heat in the body. How about the body weight? What do you think? Like you are suffering from hyperthyroidism last 1 year, body weight will go down, right? Person will get skinny because fats will be used up for metabolism. Make sense? So the person loses the body weight. And sleeplessness, easily gets irritated. Irritability increases. So the person has less sleep, gets irritated, body is always hot, and those are the changes in hyperthyroidism. Hypothyroidism is kind of opposite. If you touch the body, you will feel that body is always cold, colder than normal person. The blood pressure is low. So those are the symptoms of hypothyroidism. Hyposecretion of thyroid gland or hypothyroidism can also lead to a condition that is called myxedema. Myxedema is the condition, if you see the patient's face, it's like puffy, soft, like edema in the face, fluid in the face, okay? So that is one condition. And hypersecretion can cause a clinical condition that is called Graves' disease. In Graves' disease, of course, those symptoms that I mentioned, symptoms of hyperthyroidism will occur. In addition, but we see accumulation, abnormal accumulation of fat. Fats accumulate in certain areas in the body. This is the lower abdomen, back of the eyeball. You know, this is the orbital fossa here, right? In the orbital fossa, inside the orbital fossa, fat accumulates. So when the fat accumulates in the back of the eyeball, what will happen? The eyeballs are pushed outwards, right? Forward. So you will see that it looks like the person's eyeballs are being pushed out, popping out, okay, because of fat in the back that pushes the eyeballs outward. So that's the Graves' disease. We see those conditions in hypo or hyperthyroidism. Okay. So let's stop here today. We'll finish the remaining part in next lecture. Do you have any question?